preparations for your upcoming first professional exams. So we will be starting with the video, and thanks to Shubhamay sir for helping us for shooting this video. So let's go on. So hello everyone. So we have Shubhamay sir today with us, Head of Department of Biochemistry, Medical College Kolkata. So I will give the mic to sir.
Hello everyone, good morning, good afternoon basically. So let us start with our topic directly.
So first I would like to ask sir, what is the paper pattern of our university exams? And I would also want sir to tell about the pass and the fail criteria which has been modified recently. So I will give the mic to sir.
Well, so according to the syllabus of the biochemistry which is given by West Bengal University of Science, so it's being circulated in every colleges, medical colleges specifically. So in the first paper there is basically, mostly the basic biochemistry that is related with oxidative phosphorylation, with enzymology and the chemistries of the different biomolecules. And thereafter we are coming to the metabolism of those biomolecules, that is particularly the four, the carbohydrates, protein, lipids and the nucleotides. And it is associated with the other things, that is this with that of this acid-base balance. There is, this milieu and internal environment like this. It's also related with cell membrane. There are organ function tests and related with that of the heme degradation, synthesis and degradation and profile and all these things. So all is being related with that of the metabolism and also with that of the related disorders, and mainly with that of the both inborn and also the other disorders. Now coming to the second paper is mainly the molecular biology. And now the molecular biology, that is the metabolism of the DNA, RNA, and thereafter is related with that of the cancer, how the oncogenesis. The whole of the chapter thereafter. Thereafter we come to the vitamins and the minerals, then the Xenobiotics, which is basically one of the very catchy chapter in the second paper. And last of all, there is the hormones, there is the biosignaling, how the hormones are being working. Not pertaining to the single hormones, but it's basically a holistic approach to the biosignaling or the signal transduction. And recently, a newer chapter has been introduced, which is coming in CBME, and it's the nutrition. The nutrition is mostly some of you have read in the previous years with that of the protein malady, this sort of disorders, there is the kwashiorkor and the maximus. Now we are basically depicting the biochemistry behind it, along with that of the other biomolecules, their protein, their caloric intake, what is the difference value of a particular diet of a particular protein related with that of the patient and related with all these caloric values of this protein, fat and carbohydrate. So this is in brief about that of the first paper and the second paper syllabus given by WBHS. But the most important thing is that there is no any watertight boundary between these two. So it can be questions, can be amalgamated. So that is the bottom line of these to the students, is that whenever you are going to prepare, coming to the exam hall, so you don't think that this is in the second paper, so I am not to get the questions in the first paper. You may face this sort of questions, not directly but it's related. So this is the most important one. And now coming to the second question, what my student asked just previously, that is the pass and the fail criteria. This is a bit being modified. So it has been coming to this 40 plus 40. That is in the both papers, the minimum criteria to pass in the theory papers is 40. So 41 is the genuine pass marks in a paper, in paper 1 and paper 2. So if one student gets 41 plus 41, that is 82. And thereafter, if that student don't get the rest of the marks, that is 60. If you consider a single paper, so 40 plus 60, that is in the practical. So thereafter, it is coming to be 100. But still, if we think so, that if it is of the whole of the biochemistry, wherever we are giving the exam, or the student is giving the exam, it is better to think in this way, that each of the papers, that is 40 plus 40 minimum, so it's been 80 out of 200. So in the previously it was given that it should be 100, so thereafter this lack of 20 marks, now it is being given that it is to be corrected by the practical. So the practical portion is coming to be the 60, so we call it as 60-40. But anyway, better to think of 50 and 50, that is 100 plus out of 200 in theory, and 100, the pass marks, that is 100, 50 plus in the practical. So it's up to within 300, the minimum criteria is 150 of passing in the total. Regarding that of the practical, the important thing is that, so it will be divided into different subgroups where the number will be divided. So according to the CBME, OSPE, that is Objectively Structured Practical Examination, that OSPE should be some of the stations, and it depends upon the every colleges, whatever they select. So it can be 10 stations with 5 marks each, or it can be 12 stations with 5 marks each, whatever it is empirical, whatever the college thinks. So 50 or 60 or 40 marks in OSPE. Rest of the thing depends on a quantification of any of the analyte. It can be blood glucose measurement, it can be creatinine measurement, serum creatinine measurement, it can be serum protein measurement, total protein measurement. So in that analytical one, so quantification, so it can be 10 or 15 or 20 marks. So this is basically of the practical oriented hands-on. Rest upon the examiners or rest upon the colleges, they can go for a short note regarding any semi-auto analyzer function or anything else. And last of all, 20 marks, basically it is being given for the fibrosis, where paper 1 and paper 2 along with charts. It can be again empirical, one college can opt for 10, that is paper 1, paper 2 and the charts, the clinical charts given, so 30 marks each, or they can go for 20 plus 20, whatever will be the things. Ultimately it is of 100 marks for practical and 200 marks in 100 in each paper for paper 1 and paper 2. And minimum criteria totally is 150 plus, individually it can be 40-60. This is the bottom. Thank you.
So if you can please elaborate on the marks distribution of the paper.
Yes. Very good. Now, in the theory papers, the marks are being distributed like this. There is first of all no any options. So the questions are pinpoint. So all of the questions have to be attempted. In the first, in the first journal, there is LAQ, which is known as long answer type questions. So in biochemistry, 2 LAQs are there of 15 marks each, 15 marks each. So 2 into 15 is 30 marks of LAQ. Be paper 1, be paper 2. Now come to the second journal. The second journal is question 3 and 4 and 5. It is basically the essay. That is the short answer type questions of 10 marks each. So 30 plus, 2 into 15 plus 3 into 10. So coming to be 50. 30 plus 30. 3 into 3. So 30 plus 30 is 60 marks. And thereafter 10 marks is short note, which is 5 into 2 in both of the papers. So it's coming to be 70, and thereafter the 10 marks of the MCQ last question. So it's 80, and rest of the 20 is the biochemical explanation. So biochemical explanation usually is given as 5 into 4, that is 4 marks each, 5 questions. So ultimately is 9. So again I am repeating 2 LAQ, 2 into 15, 3 SAQ, 3 into 10, 30. So it's total coming to be 60. Then 10 marks short notes, 2 into 5, 2 short note questions, 5 marks each. Then 5 biochemical explanation, 4 marks each, so 5 into 4, 20, 70 plus 20, 90, and last 10 is MCQ. And MCQs are single answer type. It's not dual answers, straight single answer type in each of the types.
So this was all about the paper marks distribution, topics distribution, and the passing criteria. Now we'll be moving over to the important topics for which you all are waiting. So I'll move on to Shuradeep. He will ask sir about the carbohydrate chemistry as well as metabolism. So Shuradeep, over to you.
Good afternoon, sir. I would like to ask you how students should approach carbohydrate chemistry and carbohydrate metabolism for MBA exams or prof exams. Like, are the cycles important or the reactions, rate limiting phase? What are the things that students should try to focus on?
Thank you, Shobhi. Now the thing is that this is very important, again a very important question because the context has changed. So nowadays there is no any, the questions are not coming in this cycle pattern. That is how write the whole of the glycolysis or whole of the TCA cycle or whatever it is. So it is basically dependent upon mainly the rate limiting steps, the diseases oriented with it, and thereafter the first question if you see the last 5 to 6 years after the CDNE started. So there the first question in paper 1 or paper 2 is almost a clinical question, and those clinical questions are all related with metabolism. So the thing is that metabolism part is a very important one wherever we are to focus from the back side, that is the end of the thing, that what is the disease occurring, what is the enzyme deficient or dysregulated, or again I am coming to I am breaking this prototype boundary, that is what can be the mutated enzymes or a totally dysfunctional enzymes from the end of the molecular value that is causing the disorder. So this is the important thing. As for example, the phenylketonuria. So the phenylketonuria is of different types. The classical phenylketonuria is whole of the enzymes. Now thereafter the second and the third journal they are coming the second enzyme is deficient or the other enzyme is deficient, all these things. So যেখানে পুরো deficiency থাকবে সেটা একটা রকমের, যেখানে partial deficiency থাকবে সেটা একটা রকমের. So we have to think in this way, and thereafter the metabolic cycles which are being altered due to this problem. So if it is a case of phenylketonuria, you can go for phenylactate, phenylpyruvate, etc., etc., and thereafter causing the ketoacidosis or this lactate amylase. This form is called lactic acidosis. Whereas in galactosemia or whatever he was asking me that of the carbohydrate metabolism, we come to the think of fructose or the galactose or whatever it may be. So when it's complete absence of the enzyme, then the baby cannot thrive, he will die. But when there is partial deficiency, so when there is UDP, galactose uretile transferase full deficient, it will die. But when there is partial, when there is other things, without that other enzymes are absent, then there is a non-classical galactosemia. But in this context, we have to get to the galactose metabolism pathway. So in this way, the pathway is related, but it is in the light of a clinical chemistry problem, which is a clinical problem, which is the most important. It's not only for newborn, it can be from the adults also. So it is the main thing. Glycogen storage disorder. Glycogen storage disorder, it can be of the different facets. So it is the orientation is like this.
So basically, sir is wanting to tell that the applied part of the cycles is what is important, starting from glycolysis to the fructose metabolism. All the applied part is important. So, sir, I would like to ask you, in the carbohydrate chemistry, which topics do you feel are important, like the isomerism, the tests?
Yeah, the isomerism is not very pertinent again with that of a long question right now. So, but the thing is that isomerism should be in the back of his mind, because when there is any sort of metabolic disorders or metabolic problems related with these disaccharides also, so this can be a part of. Other than that, isomerism was a long question previously. But now, as there is the orientation has changed, isomerism is right now not a very pertinent to long question, but it should be in the mind. And I think the boys or the girls who are coming, I think they have an idea of this isomerism, because in their plus 2 courses, whatever may be ICC or CBC or whatever it may be, so these things are there. So they have an idea that what are the basic things, what is the anemorism, what is epimerism, and all these things. And for this is very important. Basically, the anemers. The epimers of the glucose, these are to be mostly being oriented with our things. Similarly, the structure of the polysaccharides, the hetero, the homo, and all these things. So, include the but the essence of whatever the bonding is O-glycosidic bond or this A-galactosamine or whatever is forming the hetero and the homo polysaccharides, I mean the homo polysaccharides, the glycogen and all these things. So, this is not being inculcated in them before they are being coming here. But nowadays with the time also. Now with the time. So, what is actually Shrodip is trying to tell that it is a holistic one. Now the paper want to be approaching partly to that of the metabolism. So metabolism, the main thing is that we will have to be clinical approach is the main one. Wherever we are tracking the process of metabolism, particularly with that of the enzyme deficit. So we will have to take care of the immediate what is the substrate, what is the product which is not being formed and how it is being excreted to the other, or the substrate which is being accumulating, how it is bifurcating to the other pathways, whatever the problems are being coming. So this is mainly the holistic one with that of the in general metabolism, not only with carbohydrates. It can be with lipids, it can be with amino acids and proteins. So mainly with that of the amino acids. Now the similar thing is with that of the nucleotides. Nowadays the nucleotide pathway, there is a synthesis of the nucleotides. The de novo synthesis is not being in the syllabus, in the curriculum. So it's only the salvage pathway. So students may not boggle their mind with that of this synthesis of this very it's a very out of the track pathway. De novo synthesis. I mean this de novo synthesis. So better to be of the salvage pathway or it's the salvage pathway of the purines is the mostly the question. Now coming to the degradation. Degradation of mostly the purines is again the very important one rather than that of the pyrimidine. The end products of purine and pyrimidine is to be remembered by the student minimum. These are the minimum things. Because purine degradation সবাই করবে কিন্তু pyrimidine degradation টা সবাই পড়ে so not to go for the pathway only for the end products. Okay, now metabolism and homeostasis. Now metabolism and homeostasis is basically the regulation of the integration of the metabolism that is between these three, that is protein, lipid and the amino acids. Since সেটা মধ্যে integration, now the integration is of the different enzymes, different pathways, those are being taught one after another in the different cycles. So this has to be amalgamated. This is the main thing. So how mainly related with that of the protein and the amino acids and the carbohydrate. So how the carbohydrate is going for the the amino acids are coming for the synthesis of the carbohydrates, that is the DCA cycle and periodic reactions. And thereafter the lipid metabolism, the acetyl CoA, how or the malonyl CoA, how it is being related with that of the carbohydrate synthesis again gluconeogenesis pathway that you have asked. Or from the carbohydrate, how it is going to the synthesis of the lipids. So these are DHC phosphate. So these are basically the mostly the important pathways which have to be remembered. মনে রাখা ঠিক আছে এছাড়াও তো আরো যেগুলো মানে সিম্পল জিনিসগুলো আছে these are mainly that of the different types of the enzymes and all these things which are related with this এরপরে যেটা আসবে সেটা হচ্ছে বেশ কিছু বইতে ভালো বইতে যেমন হোমিওস্ট্যাসিসের ক্ষেত্রে ডিফারেন্ট ইয়েতে যেমন the most common thing by the integration is basically how many days the patient can survive with this particular biomolecule, how many days more with this, how many days more with this, or a runner is running a 100-meter sprint or a 1,000-meter or a marathon. So whatever be the metabolites are coming in these facets. So these are basically the main things which are being related, a bit of clinical approach or a bit of practical approach which is being coming in the facet of the metabolism. Okay. So this homeostasis is also being, if I think, it can also be in the cancer also. So it's a part 2 question, paper 2 question, where the cancer is mostly related with that of the glycolysis. It's a deviated pathway. So that is also being a cancer homeostasis. I mean the change in the pathway, but that is a different phase which is being related with that of the metabolism also. Now coming to the acid-base balance questions are mainly the SAQ questions, mainly the 10 marks question, where a problem will be given on the main 4 types of the metabolic or respiratory acidosis or alkalosis. Metabolic acidosis, alkalosis, respiratory acidosis and alkalosis. The student has to identify which component and whether it is acidosis or alkalosis on the basis of mainly the bicarbonate in metabolic fraction and the PCO group in the respiratory fraction. And thereafter, they have to deduce which of these is the cause of whatever be the condition, and the compensatory mechanism is usually a part of the question which is being asked, how this can be compensated, either it's in a compensatory phase or how it can be compensated. So এই জায়গাটা একটু নিজেদেরকে physiology এবং biochemistry মিলে you will have to answer the question thinking of the thing. Just now it's coming to be the next one is the cell membrane. So cell membrane long questions are not usually doesn't come nowadays, but it can. So there are the models of the cell membrane. These are the very important. Then we are coming to the different channels. I mean the transport across the cell membrane. It can be the small molecules, it can be the large molecules. So these just now the tissues. Then it can be active or passive. As a important one is just because it has been a long time. This question usually comes as a short note. It is sodium potassium. So it's an active transporter. So thereafter it's inhibitors and all these things. This can come as a short note. Okay. And if we think of nowadays, in GLUT, glucose transporter, SGLTs, this is the thing. Even the larger molecules, they are coming as a short note. So endocytosis, exocytosis, spinocytosis, and all these things. It will short note asking for it. Then the specialized membranes, specialized structures of the membranes, the lipid draft, these raviolis and all these things, they are being related with that of the cell signaling. Cell signaling asking into second paper. So membrane is in the first paper. So there is a cross talk between the first and the second paper. Okay. Then coming to the organ function test, these are mostly related with the clinical cards, whichever may be present in each of the colleges. And mostly for UG purpose, we usually being referred to the LFTs, the liver function test and the renal function test, whereas adrenal, pancreatic, gastric, and etc. They are mostly being asked in the Bible, mostly, but it's not again about it. Then coming to the heme synthesis and degradation, I think this is again a part of metabolism. It's not to be a separate entity because heme is a protein and heme synthesis and all these things is related with that of the protein metabolism. And heme synthesis and degradation is very important, pertinent to the glycine as being the starting of the heme synthesis. Even the breakdown when the enzymes are being degraded is the porphyria. So related with that of the porphyria, again a clinical question you can go inside that of the this metabolic question. So this is mainly related with that of the first paper. So chemistry and metabolism and other things, I just tell you, apart from being in the process, think of the clinical issues or the applied ones which are being very much pertinent with these topics mainly. Okay.
So in paper 1 we just missed the enzymology part, if you can elaborate on that.
Yeah, so actually enzymology part is a very important one. Now regarding the enzyme, usually the questions used to come that of the classification of the enzyme, which has to be mentioned by the IUPMB classification. That is whatever the International Union has given. It again নিজের মতো বললে হবে না, with one example each. It is basic. Then we are coming to the different types of the different types of the enzyme catalysis or whatever may be the types of the the enzyme have been what? So nature of the enzyme catalysis and what are the modalities of the enzyme catalysis. So these are being the thing. Now there is a very shady part, a gray area that is basically the different orders of the reaction and all this. I think in the UG level, if this is not a very big deal. I think the students should bubble with this one. The important thing is that we got the inhibition part, enzyme inhibition, where the three types of inhibition, mostly the first two, that is competitive and the non-competitive, these are being mostly given. So students have to concentrate on this one with an example, and the most important thing is that the related diagrams, mostly with that both in the type of Michaelis-Menten curve and with that of the line-Weaver bar plot or the double reciprocal. এই দুটো ছবি বাড়িতে প্র্যাকটিস করতে হবে, দুটো কম্পিটিটিভ এন্ড নন কম্পিটিটিভ। আদারওয়াইজ it looks easy, it seems easy when we are reading, but whenever the question comes you have to write it of your own or draw it of your own. Thereafter there can be a sum of the problem. So this, I think this should be done by a student just before the exam. This is a very important thing. Next we are coming again to the applied one. So what is the clinical enzymology? What are the enzymes which are being needed in these different types of the function test to come to a diagnosis? So this is one part. So some of the enzymes which are being utilized in these diagnostics, they are examples. So these are the very important things, that is the functional and the non-functional enzymes. Eগুলো কিন্তু আমাদেরকে ছোট ছোট করে জানতে হবে। Another very important thing is related with that of the minerals and enzyme. That is which of the minerals are taking part in the enzyme work. That is there are two classifications. One is a metal low enzyme and another is a metal activated enzyme. এই দুটো কিন্তু প্রত্যেকটা স্টুডেন্টের ঠিকভাবে জানা উচিত কোনটা এক্স্যাক্টলি কি এবং what are the important enzymes which are having the cofactor metals or metal is acting to help them to work, and with example. This is very important, and the diagram which I just said with that of the Michaelis-Menten analysis and Michaelis-Menten equation. Michaelis-Menten diagram of the inhibitions along with that of the line-Weaver bar plot. And why the line-Weaver bar plot is important in this inhibition rather than that of the MM plot or the MM plot is LWB line-Weaver bar plot is important more than that of the Michaelis-Menten. Why? In case of a enzyme inhibition depletion. This is important.
So this was all about paper 1. Now we'll be quickly moving on to paper 2. So I request Shubhani to ask sir about the paper 2 topics. So Shubhani, over to you.
Sir, regarding the paper 2, এটা অনেক স্টুডেন্ট এটা পড়েছে, তো স্যার পেপার 2 মানে হাউ টু অ্যাপ্রোচ পেপার 2 অ্যাজ আ হোল এন্ড হাউ টু এস ইট।
And what's it about? Because molecular biology is really a tough thing. And the most important thing is this is the area where which I think you have not come across with this. You have to learn that তোমাদের কিছু সেরকম ভাবে ছিল। Now the thing is that in case of molecular biology, the basics, the central dogma of the molecular biology should be known. That is the process. মানে যেগুলো আমরা জানি, replication, transcription, translation, or reverse and all this. এটা আগে আমাদের জানতে হবে কোনটা কোন জায়গাতে হচ্ছে এবং সেখানে মেইন এনজাইম, হোয়াট ইজ দ্য মেইন এনজাইমস, এই তিনটে জিনিস আগে ক্লিয়ার করে নাও একটা খাতা। কোন মেইন এনজাইম, ডিএনএ পলিমারেজ, আরএনএ পলিমারেজ। এই ট্রান্সলেশন হতে পার্টিকুলার কোন এনজাইম নেই, বাট देयर ইন অ্যামিনো অ্যাসিড পেপটাইড ট্রান্সফারেজ, অ্যামিনো অ্যাসিড ডিআরএনএ ট্রান্সফারেজ এন্ড অল দিস। এনিওয়ে তো এই জায়গাটা ইম্পর্টেন্ট, যেমন রিকম্বিনেন্ট ডিএনএ টেকনোলজি দ্য মোস্ট ইম্পর্টেন্ট ইজ রেস্ট্রিকশন টেকনিক। তাহলে এটা একটা খাতা আগে রেডি করে নাও। দেন কামিং টু দ্য ইচ ওয়ান, রেপ্লিকেশন, ট্রান্সক্রিপশন or translation. The thing is that recently, after recent 2 to 3 years, the question that it has got two phases. One is the prokaryotic, one is eukaryotic. Prokaryotic is a bit easy to remember for you, but এটা কিছুটা তোমরা এর আগে পড়েছো। But eukaryotic one, there is a huge difference, both in the naming of the enzyme, classification of the enzyme, what module, because there is no aim. And the most important thing is that we the teachers also just couldn't highly explain the whole of the thing to you. It's also a lacuna in our part also. Then how to approach? The approach is that to me, যেটা আমি আমার স্টুডেন্টদেরও বলতাম, so first of all you grasp the prokaryotic and fully যে এটা আমি একদম জানবো কোথায় করব, and thereafter you just arrow and point out that what the places which have been coming in the eukaryotic. Just ডিএনএ রেপ্লিকেশনে যখন করবে তখন ইনিশিয়ালি উইথ দ্য স্টার্ট অফ দ্য রেপ্লিকেশন ইনিশিয়েশন ফেজে যে প্রোটিনস গুলো লেগেছে দ্যাট মিনস সিঙ্গেল স্ট্র্যান্ড প্রোটিন ইট ক্যান বি ডিএনএ হেলিকেজ এন্ড অল দিস প্রাইমেজ এন্ড অল দিস তাদেরই আরেকটা করে নাম হয়েছে ইউক্যারিওট অলমোস্ট। তো গেট আ প্যারিটি উইথ দ্যাট, তাহলে আমরা কিছুটা হলেও তোমাদের মাথায় রাখবে। এবার ডিএনএ পলিমেরেজ 1 2 3 ডিএনএ পলিমেরেজ ওখানে মানে the eukaryotic names have been changed, RNA polymerase 1 2 3 eukaryotic names have changed. So the genre is changing, definitely the genre is changing, but we have to remember with that of the it's my dictum is that I maintain this protocol and tell my students that go to the prokaryote first, then with that just you adapt with that of the eukaryote. What are the changes and what are the nominal things we have to do? We don't have to go for the very depth of the thing always. It is a part. Second part is that in case of the eukaryotes there are some of the differences also grossly, as for example the end replication problem in eukaryotes. So this is the problem. So here we have to get with that of the different types of the things, other things. Similarly, in case of the transcription also there are so these modalities are being changed, the post-transcriptional modalities, which is mostly when it's for the eukaryotes. So this is again a different facets. এবার এখানে অন্তত তুমি যদি পুরোটা না জানো অন্তত নামগুলো যে পলিএডে this intron splicing, this one is cell metabolism triphosphate, I mean the capping and this intron splicing অন্তত নামগুলো intron splicing এর বেসিকটা তোমাকে তুমি অন্তত বলতে পারবে না, কিন্তু এই দিনটা কি কোথায় কি হচ্ছে এই দিন। Similarly, if you come to the translation, eukaryotic, prokaryotic, both are tough because we have to remember the various subunits of the ribosome, 48, 68, and 58, 38, and all these things. Thereafter, they are coming the tRNA, mRNA, and this is a full cluster of all the RNAs, and ultimately the protein is being synthesized. But শুধু একটাই এটা তোমাদেরকে বলার চাই, usually the most important thing to the UG level আমরা যেটা চিন্তা করি সেটা হচ্ছে the process of the initiation, difference of the process of initiation between prokaryotes and eukaryotes in all the phases. এটা কিন্তু আগে মাথায় রাখো। Be it in replication, be it in transcription, be it in translation. So there are differences. Same differences protein gulo, same differences enzyme and consensus sequences, translation of that prokaryote eukaryote consensus sequence difference. So এই জায়গাগুলোকে একদম খাতাতে লিখে ফেলো prokaryote eukaryote what are the differences. Then you just amalgamate that thing and that thing. Then another facet is that of the DNA break repair. So what are the causes of the DNA break? What are the types of repair? And the mostly যেটা আসে আমাদের that is a base excision or the nucleotide excision এগুলো বেশি আসে, তার থেকে ডাবল স্ট্যান্ড বাই এগুলো খুব বেশি আসে। Xenobiotics related to that the xenobiotic pigmentosa, the hereditary non-polycystic HBCC, hereditary non-polycystic colon cancer. So these are all being related. So here in the previous year I have seen a question of xenobiotic pigmentosa. তাহলে xenobiotic pigmentosa থেকেও ব্যাক করে তোমাকে জিজ্ঞেস করতে পারে nucleotide excision রিপেয়ারটা কোথায়। আবার nucleotide excision রিপেয়ার ডাইরেক্টলি তোমাকে শর্ট নোট তাহলে তোমাকে এন্ট্রি দিতে হবে। So it's xenobiotic pigmentosa is the cause of this faulty repair system. So it is legal cycle. So এইভাবে পরপর so it is related with the first three. Then we are coming to the gene expression. Prokaryotes is the most. তাহলে lac operon system একদম মনে রাখতে হবে। Three conditions where the lac operon is how it is being working. So glucose abundant, glucose main, and glucose minus, lactose plus, lactose minus, and where glucose and lactose both are present. বাস এটা মোস্ট। এবারে ইউক্যারিওটের ক্ষেত্রে এই জিনিসটা থেকে ডেভিয়েট অনেকটা। ইউক্যারিওটিক জিন এক্সপ্রেশন ইজ ডিফারেন্ট। Here it is basically the sum up of all the processes, replication, right from starting of replication, transcription, post-transcription, translation, post-translation, all these things. তাহলে এই জায়গাটা পড়া একটাই কারণ আমি যেটা তোমাদের জিন এক্সপ্রেশন ইনকারেক্ট এখানেই বলবো। So it will help you at least in the transcription and the translation that it will help you to see that what are the things you have left behind. যেগুলো পড়ো যেমন post-transcription আমি বললাম post-translation is very important as a regulation of gene expression in eukaryotes. But maybe you have left while you are reading with isolated translation. কারণ আজকে তুমি গ্লাইকোসাইলেটেড প্রোটিন কি ফসফোরাইলেটেড প্রোটিন এটা না জানলে তুমি এই যে হিস্টোন বা তার ব্যাকে যে তুমি রেপ্লিকেশনে হিস্টোন পড়েছো তাহলে তোমার হিস্টোন মডিফিকেশনটা কিন্তু তোমার মাথা থেকে বেরিয়ে যাবে। কি একটা প্রোটিন গ্লাইকোসাইলেটেড হচ্ছে সেটা গ্লাইকোসাইলেশনটা যদি না হয় তাহলে সেই প্রোটিনটা গিয়ে অন্য জায়গাতে যদি জমে দিস ক্যান কজ আইসেল ডিজিজ অর ইনক্লুশন সেল বডিজ লাইসোসোমাল ডিসঅর্ডারস। সো সেটা কি দাঁড়াবে হচ্ছে তোমার আই মিন দ্য ইম্পর্টেন্স অফ দ্য মেটাবলিজম। সো এখান থেকে আবার বেশ কিছু জায়গা আসবে যেগুলো পড়ে আমার ক্লিনিক্যাল প্রবলেমস কি দাঁড়াবে বা আমার হিস্টোন মডিফিকেশন যদি ঠিক করে না হয় তাহলে সেখানে ডিএনএ খুলবেই না, ডিএনএ সেখানে আনবিল্ডিং হবেই। So this is all related with this next. The important one is the recombinant DNA technology. So recombinant DNA, the basics of the RDT related with that of the restriction in the nucleases. What are the cuts of the restriction in the nucleases? This is very important. Then coming to the vectors, that is the names of the vectors where the host DNA can be, when it is being included. How many base pairs are being for the different types of the vectors? And thereafter, the last of the thing, there are various techniques, how it can be amplified by the PCR, how it can be seen by different plotting techniques, and thereafter the various important ones, that is this restriction drop fragmented polymorphism, this fluorescent in situ hydration. These are the techniques of the RDT. অন্তত এগুলো নামগুলো ফুল ফর্মগুলো মাথায় রাখতে বেশি কোনটা থেকে কোনটা হচ্ছে। Similarly, plotting also কোনটা থেকে কোনটা হচ্ছে। DNA mutation is very good. The mutation is also very important in genetic coded mutation. So genetic coded mutation is a very important thing where genetic coded যাদের characteristic এটা পুরো মনে রাখতে হবে আমাদের। Mutation is a very important chapter for engineering. Types of mutation with example and whatever. But I mean this is the most along with friendship. কারণ মিউটেশনের সঙ্গে কিন্তু ইনিশিয়ালি ফ্রেম শিফটটা বলা হয় দেয়ার আর সেকেন্ড পার্ট মানে মিউটেশন দেন আই মিন দ্য পয়েন্ট মিউটেশন এন্ড দ্য ফ্রেম শিফট মিউটেশন এবারে ফ্রেম শিফট মিউটেশনটা কিন্তু তোমাদের আগে কিন্তু শর্ট নোট এসেছে so both of the things are to be important and related with this point mutation and all this the sickle cell disease or the thalassemia whatever it may be so sickle cell is a very important one which is related with mutation which is related with abnormal hemoglobinopathy so paper 1 and paper 2 again is being amalgamated তাহলে সিকেল সেল থেকে কোশ্চেন এলে তোমার আগে মিউটেশনটা বলতে হবে তারপরে তার সিকলিংটা কেন হলো সেই সিকলিংটা তুমি তার জন্য তোমার হিমোগ্লোবিনের কি প্রবলেম হলো পেশেন্টের কি প্রবলেম হচ্ছে এই গোটা জায়গাটা থেকে তোমাকে আনা ওকে সো দিস ইজ again where both of the papers are being amalgamated the recombinant mutation the recombinant technology mutation genetic code হয়ে গেলে last of all আসছে ক্যান্সার cancer is a different genre different facets there are lots of definitions which are to be gathered first oncogene proto-oncogene this is the thing then how the proto is being converted to onco there are different mechanisms how these proto-oncogenes are being inserted in our body into the different at least the name the transposable elements transposons and thereafter they are hacking our full body mechanism the different metabolisms and thereafter it's just smashing us এই যে জায়গাটা what are the metabolic roles there again comes the mechanism যেটা একটু আগে বলে দিলাম so cancer glycolysis Warburg phenomena this is the most important thing it can come in part 1 I mean first paper it can be of the paper again apart from that there is protein malnutrition cachexia যেটা আমরা বলি it's a lipid alternation so cancer is basically the whole of the thing is basically the again এবার সবাই ভাবো যে এবার ক্যান্সার is again being related with that of the telomeres where the replication problem was there যেটা আমি তোমাদের একটু আগে replication বলেছি so তাহলে বুঝতে পারছি telomeres যদি ওখানে ছেড়েও আসে কেউ যদি ভাবো যে আমি করতে পারলাম না বুঝতে পারলাম না তোমার কিন্তু ক্যান্সারে এসে তোমাকে জানতেই হচ্ছে বিকজ they have their own telomeres এখানে telomeres এর কোনো গল্প থাকছে so telomeres জিনিসটা তোমাকে জানতেই হবে so eukaryotic replication with telomere replication problem and again related with cancer so there again the paper one I mean the two of the different metabolic process are being amalgamated both in paper ঠিক আছে এটা এগুলো বেসিক্স কিছু ক্যান্সার মেটাবলিজম থাকলো এছাড়া এবারে ইয়েস অ্যাপোপ্টোসিস দ্য মোস্ট এগেইন অ্যানাদার ইম্পর্টেন্ট লাস্ট একটুখানি করে আছে অ্যাপোপ্টোসিস না অ্যাপোপ্টোসিসের তাই একই কথা বলবো জাস্ট গেট দ্য পিকচার বেশি করতে হবে না যারা একটু ভালো বুঝতে পারছো মনে হচ্ছে আমরা গ্রাস করতে পারছি জাস্ট গেট দ্য পিকচার ইন্ট্রিনসিক এক্সট্রিনসিক what is the main enzyme caspases these are cysteine proteases what are which of the enzymes are related with classical or the I mean the intrinsic and extrinsic pathway and how ultimately the cell is being going to the death domain তারা মরছে মারা যাচ্ছে এই death domain in this molecular biology there can be different types of the genes which are helper and which are not being helping so এই জায়গায় এখানেও বেশ কিছু জিনের নাম আছে যেগুলো এমসিকিউ তোমাদের আসতে পারে ব্যাড ব্যাক্স এগুলো আবার ঠিক এই ডিস্ট্রাকশন বক্সে কিন্তু আরেকটা কনসেপ্ট হচ্ছে প্রোটিন ডিস্ট্রাকশন যেটা আমরা পেপার 1 এ সবসময় পড়া হয় না which is mainly related with the destruction of the protein that is proteasome ubiquitin complex normal degradation because turnover is a very important thing of the human metabolism তৈরি না হলে শেষ না হলে তৈরি হবে না আর এই প্রসেসটা না তৈরি এই প্রসেসটা না চলে মেটাবলিজম হবে so turnover is important and proteins are mostly being turned and this is why the ubiquitin proteasome complex এবার কিছু প্রোটিন আছে তারা ডিগ্রেড করতে পারে so catalysis to lysosomal degradation কিছু প্রোটিন আছে they can be degraded to this ubiquitin proteasome pathway so এই জায়গাগুলোকে এই তাহলে একটা ডিগ্রেডেশন মানে আমি পেপার 1 এর একটা ডিগ্রেডেশন বললাম পেপার 2 এর একটা বললাম যেটা জেনেটিক ডিগ্রেডেশন যেখানে হচ্ছে শুধু অ্যাপোপ্টোটিক পাথ দিস অলসো প্রোগ্রাম সেল এটা আরেকটা নাম হচ্ছে প্রোগ্রাম ঠিক আছে দেন Xenobiotics is a very catchy chapter very easy chapter just পড়লেই হবে কিন্তু সাইটোক্রোম B450 টা একটু আলাদা করে পড়ো বারবার সবাইকে বলা because it's a very important enzyme where it is located what are the types of the enzyme mitosomal mitochondrial what are the different mutational problems with cytochrome B450 and all these things so is a cytochrome B450 is very important and related issues with that other drugs because drug metabolism is very much related with cytochrome B450 and even not even like that not the alcohol the smoking tobacco these are also being eliminated from the body by through these cytochromes so this is very important not only with your BPA but you will have to cope up with these types of cytochromes in your practicing life also so get a thing of it and in a book there it is already being given in a good short form just only get it পড়তে হবে ভালো করে and the full forms cytochrome CYP1A1 what does it mean similarly description into nucleus eco R1 what does it mean so এই জায়গা এগুলো কিন্তু ইম্পর্টেন্ট সেটা যে কোনো কারণে ঠিক আছে ফুল ফর্ম the genre I mean the family sub family family so all this is even the IUPAC classification of enzyme একটা এক্সোকাইনেজ এর চারটে কিছু so what are those dependent এইগুলো কিন্তু just a very important for the Bible questions even for the theories also okay now coming to the hormones is again a very different but important but to the UG students the basic level is the biosignaling this is the most important thing biosignaling hormones বা signal transduction বলে এটাকে how the hormones are transduced a hormone is a minuscule quantity খুব অল্প পরিমাণে থাকে now when it is working like 1,000 times more so how is it possible so it is possible through this cascade is known as the signal transduction so there can be two hormones সেগুলো একটা হচ্ছে ectonuclear receptor একটা হচ্ছে cell membrane receptor টাই mainly উজিতে আসে these are mainly the G protein coupled receptor where the second messenger is the cyclic Second question is cyclic GMP, just দুটো করে হরমোন অন্তত মাথায় রেখো। Then this is the tyrosine kinase or the insulin is being active. Then the Jasted pathway, নামগুলো অন্তত where the growth hormone and prolactin is being working. Then the NF compatibility, NF compatibility মধ্যে নেই, যদি কেউ ভালো বলো তাহলে জিজ্ঞেস করতে পারে ভাইভাতে is the corticosteroids. Just নাম আসো। এবার এটা কেন বললাম? এটা কেন বললাম? কারণ মেইন গ্রস দুটো মনে রাখা, একটা ইনসুলিন আর গ্লুকাগন। Because these two hormones you have covered in paper 1. In all the metabolism, whatever may be, is the carbohydrate, protein or fat. এই দুটো হরমোন কিন্তু মেইনলি কাজ করছে। এবার গ্লুকাগনের অনেক বন্ধু আছে, তাদের অ্যাডিনাল হরমোনস আছে, তারা সব 5 জন মিলে একা ইনসুলিন ফাইট করছে। ইনসুলিন কাজ করে tyrosine kinase দিয়ে, which is class 2. গ্লুকাগন এবং তার বন্ধুরা কাজ করছে to the protein terminal receptor to cyclic AMP. তাহলে আবার যদি ফার্স্ট পেপারের কোশ্চেনে ইনসুলিন আর গ্লুকাগন থাকে, গ্লাইকোজেন রেগুলেশন অফ গ্লাইকোজেন, রেগুলেশন অফ গ্লাইকোজেনেসিস, গ্লুকোনিওজেনেসিস এন্ড গ্লাইকোলিসিস বাই BFK2, তাহলে এই প্রত্যেকটার মধ্যে কিন্তু ইনসুলিন আর গ্লুকাগন থাকে। এবং ইনসুলিন আর গ্লুকাগন যদি কখনো কোনো কোশ্চেনে এখান থেকে কেউ বুঝে থাকে হাউ দে আর বিং ওয়ার্কিং, সো এগেইন দেয়ার ইজ অ্যামালগামেশন অফ পেপার 1 and 2. Where signal transduction, the process of the signal transduction is going on to paper 1. Okay. I mean, lipophilic class 1 ছেড়ে দিলাম। Class 1 is related with the mainly with that of the molecular biology, where there is transcription and different hormone response element and all these things. Even এটা ছাড়াও steroid hormones, so it's being steroid hormones one part, class 1 steroid hormones one part, and another one is the vitamin D, thyroid and the retinoic acid. Retinoic acid are coming in vitamins. So one part of the retinoic acid is going as a helper in this class 1 hormones as a second, not a second, but it's being the receptor, it's binding to the second one. So তাহলে back হচ্ছে যে vitamins one facet is for I mean vitamin paper 1, paper 2 and this hormones, so এই দুটো কিন্তু it is being again amalgamated. So these are the basic things. এগুলো একটু মাথায় রাখতে হবে হরমোনসের বায়োসিগন্যালিং এ আমরা কোন কোন হরমোনগুলোকে নিয়ে কিন্তু বেশি ভাবছি। যেমন থাইরয়েড হরমোনস, if you consider থাইরয়েড হরমোনস যদি বলি তাহলে বা থাইরয়েড রিলেটেড হরমোনস যদি বলি তাহলে T3 and T4, T3 and T4 they are mainly working to the nuclear receptor class 1. TSH stimulating hormone thyroid gland, it is mainly working through cyclic AMP. Whereas TRH it is being working to the this calcium ion three part as a second. So here also that একটা organ তিনটে level of hormones, এটা তো আমাদের জানা TRH, TSH and T3, like একটা জায়গা কিন্তু একটা জায়গা থেকে signally the transduction of the biosignaling is being working. So it is the amalgamation of the intracellular and the nuclear and the cellular receptor, and this is known as the crosstalk. এটাকেই বলা হচ্ছে crosstalk. ঠিক আছে? So just আমি তোমাদের briefly বললাম, এত ডিটেইলে না গেলেও অন্তত জিনিসগুলো কিন্তু মনে রাখতে হবে। ঠিক আছে?
So few topics are like vitamins and minerals and immunity.
Vitamin and minerals are linked with metabolism, nothing more. কারণ এগুলো থেকে vitamins, minerals থেকে metabolism বেশি ঢুকবে, and those are mainly related with the amino acids and all these things. Cofactors, related cofactors which are being working from the vitamins, the coenzymes or the cofactors, I mean the coenzymes which are being coming, they are all related with metabolism. As for example, যেমন সবাই সব সময় বলা হয় pyridoxal phosphate and it's being in the transamination reaction. Thiamine, TPP is coming in the this dehydrogenases, all these enzyme complexes. So these are the things which are being very much related with this. এছাড়াও ভিটামিনে কিন্তু প্রচুর বায়োকেমিক্যাল এক্সপ্যানশন আছে, মেইনলি উইথ নিয়াসিন। So vitamins again, so it's not a big deal. Just think of the vitamin, think of the coenzyme and where it's working in the metabolism. Different types of the biochemical expansion related with vitamin. এটাও খুব ভীষণ ইম্পর্টেন্ট। As for example niacin, as for example thiamine. So এই জায়গাগুলোতে কিন্তু প্রচুর জায়গা আছে যেগুলো কিন্তু biochemical expansion দিয়ে হতে পারে। It can be from vitamin K cycle. Vitamin K cycle is important for short term. Role of warfarin and role of warfarin, how it is being working and how it is working with the vitamin K, vitamin K cycle and warfarin data. ঠিক আছে? So এই জায়গাগুলো কিন্তু ভিটামিনের সঙ্গে রিলেটেড and immunity is basically different genre. So immunity থেকে as for example the basic thing is very preliminary, structure of the immunoglobulin, types of immunoglobulin, full structure, that is the light chain, heavy chain, FAB, FC and all these things, where it is related with that of the complement, এটা important, where it is the antigens are being taken up by the immunoglobulin is the second one, তাহলে এটা হচ্ছে very important. এরপরে second genre of questions যেটা আসছে immunoglobulin থেকে is basically the NACs. So major histocompatibility complex, major histocompatibility complex is basically 1 and 2 are there, and they are basically the antigen presenting cells with the help of the T cell receptors, and ultimately they go for the death of the pathogen. So this is the most important thing. এইটুকু একটা বেসিক আইডিয়া তোমাদের জানতে হবে। আর যে কমপ্লিমেন্ট যেটা বললাম, কমপ্লিমেন্টের অন্তত কোনটা I mean there are two pathways, one is the classical pathway and another is the alternative pathway. তাহলে এই দুটো থেকে কোন কমপ্লিমেন্টগুলো আসছে, how they are being linked with that other কোন জায়গাটাতে লেগে থাকছে, একটা অ্যান্টিজেন অ্যান্টিবডি কোথায় কি আছে। So variable region, এটা যেমন হেভি চেনে কমপ্লিমেন্ট পাথওয়ে, এগুলো যেমন variable region, what is variable region, what is hypervariable region, where are the disulfide bonds. So these things are the basics of the, এবার এগুলো থেকে দুটো আছে যদি কোনো সময় শর্ট আছে, one is the ADA deficiency and one is the SCID, where there is a complete immunodeficiency, combined immunodegeneration. এগুলো হচ্ছে এদের এই সিস্টেম, though these enzymes are not here, these are not very important, the enzymes are not related with immunology, they are the other way, but related with this, they are after the immunodeficiency occurs. এছাড়া তো HIV আছে, বাট HIV আজকাল খুব একটা আসে না। এখন যদি ভাবো যে নাও দ্যাট ইজ আ কোভিড, now COVID is basically an RNA virus, so we'll have to consider with that of the reverse, that of the from DNA to RNA আমাদের এটা ট্রান্সক্রিপশনাল লেভেলে রিভার্স ট্রান্সক্রিপ্টেজ এইভাবে ভাবতে হবে। তাহলে এইটাও কিন্তু তোমাদের যে কোনো একটা ভালো বইতে ইউ ক্যান হ্যাভ আ পিকচার যে হাউ দ্য RNA virus is thereafter transcribing and putting the cDNA or the complementary DNA in our host cell, and however in that process they are basically encroaching in our body immune system. এটা কিন্তু ছোট্ট করে একটা ডায়াগ্রাম আছে, ওটার নামটা আমার ওপেনলি বলা উচিত না, বাট ইট ইজ ইন বুকস, it is in good books. So in the time of COVID, when CDB started, this was a very hot question. So how this RNA virus, COVID virus, is encroaching inside our body? So molecular biology itself incoming, and with that of the recombination, it's been encroaching, entering in our, not recombination, not in vitro, but it's in vivo, how it's been entering in our body.
So Shaf, can you ask about the practical quickly?
Now, first of all, explain why. Explain why. You just see there are 5 questions of 4 marks each. This is very pertinent. But please don't think that 4 marks দেওয়া আছে মানে আমাকে প্রচুর লিখতে হবে। The answer is mainly 1 or 2 words or a sentence. That sentence is the key sentence. What is the key word? এইটা আগে মাথায় রাখবে। তোমাকে বেশি কিছু লেখা দরকার নেই। এটা ফার্স্ট সেইটুকু লিখলেই তোমার হবে। Just you will get at least 3 out of 4 or 4 out of 4. No issues. এটা একটা there is no any boundary. It can be paper 1, paper 2, amalgamated থাকতে পারে, যে কোনো জায়গা থেকে আসতে পারে। Now regarding writing of the question before I come to the practical, এটাও আবার অনেকে জিজ্ঞাসা করে, আমি না বলেই দিচ্ছি, সেটা হচ্ছে it depends upon the person itself. সে কতটা লিখবে। থিঙ্ক অফ দ্য আনসার, বারবার বলছি থিঙ্ক অফ দ্য আনসার, যে এটা হাউ ইজ ইট পার্টিনেন্ট টু দ্য নাম্বার, কোয়েশ্চেনে যে নাম্বারটা আছে সেই অনুযায়ী আমার লেখাটা হচ্ছে কিনা। ফার্স্ট অফ অল নাম্বারটা কতটা আছে সেটা না, কোয়েশ্চেনটাতে কতটা আমার লিখতে হবে সেটা আগে ভাবো। সেটা দেখে নাও, নাম্বারটা দেখে নাও। হ্যাঁ, এবার তুমি অনেকটা জানো, তোমার দেওয়া আছে 2, তাহলে সেইটুকুই লিখবে যতটুকু তোমার প্রয়োজন, তার বেশি লিখে লাভ নেই। সো ইটস ভেরি মাচ এম্পেরিক্যাল, নিজের মতো নিজেকে যেভাবে প্রিপারেশন নিচ্ছ সেইভাবে লিখতে হবে। ডোন্ট লিভ এনি কোয়েশ্চেন, যতটুকু জানো ততটুকু লিখো, because there will be scope for the examiner to give you at least a few marks if possible. Please don't leave any question যে জানি না পারবো না তা। থার্ড, সেটা হচ্ছে don't write the answers haphazardly. If one first question is having 5 or 4 subparts A, B, C, D, E or A, B, C, D, you have written A, B, C, then D and E in the 11th page or the 13th page, then it's totally ridiculous. Because it's not possible for an examiner to go through 10 pages more and see wherever you have written one B or one E. So obviously your numbering will hamper. Numberটা কিন্তু ঠিকমতো হবে না, এটা কিন্তু সমস্যার কারণ হবে পরে। Now coming to the practical, there is a definite one. It has been given that there should be an OSPE, objectively structured practical examination, where there is some stations. Each station, according to the college, it can be of 3 marks or 5 marks. So usually 10 station or 3 or 5 or 6, whatever it may be, they are there. So you will have to move in that fashion and complete the exam within 1 hour or 1.5 hour or 45 minutes, whatever it may be. Then a quantification. Usually a quantification is done in a student's colorimeter or in a semi-auto analyzer. Thereafter you have to perfectly quantify the analyte given. It is usually being given the glucose or the the protein, total protein or the creatinine or etc. Whatever it may be, the college thinks so, or the department thinks so. Okay, it contains some marks. Third, let's say there can be some explanatory within the domain of the practical. Any of the Beer-Lambert's law or the filters of a semi-auto analyzer or an auto analyzer. So these sort of the things. So these are basically the to-do list or the modality of a practical examination. Now in the practical examination, the second part is coming the Biochemistry, where there are 2 to 3 tables. It can be paper 1 table, paper 2 1 table, and clinical charts or clinical chart related question in another table. So 10 marks, it can be of 10, 30 marks, it can be of the 20 marks or whatever it may be according to the department, or it's according upon the department to take the decision. So totally it will be of 100 marks. So in each of the things, it's a request as a teacher to the students, whichever college may be, maintain the OSPE properly, do the OSPE properly, because if you are doing it in a haphazard way, the next friend of you, he will be in a soup. If you have opened or if you have taken through the last pipette the benedict reagent and thereafter you have broken it or you have put it aside or whatever it may be, or you have just put it in the rack itself again, and if there is unlabeled benedict, so he can take the pipette reagent instead of the benedict. So maintain the decorum, maintain the sanctity of the OSPE, do the test, and teachers are there, so everything will be in a smooth. Okay?
So lastly, I will thank you, sir, so much for giving your valuable time to us, and I will ensure that it will definitely help the students who are suffering from anxiety before the exam, and they will definitely have some idea about how to write the questions and the answer in the exam. So thank you, sir, again, and we will end our session. It was very helpful, sir.
Thank you.